Welcome to an exploration of one of the most fundamental machines in modern engineering, the centrifugal pump. From water treatment plants and chemical factories to our very homes, centrifugal pumps are the unseen foundation of fluid movement in modern infrastructure. At its most fundamental, a centrifugal pump draws fluid in through its suction port. The heart of this operation is the impeller, a rotating component with a series of vanes. This increased velocity is then converted into pressure energy within the volute casing before the fluid exits through the discharge port. We see the discharge port. The fluid leaves the impeller and is guided through the volute, exiting the pump under pressure. The impeller draws the fluid into the suction port, accelerating it radially before it is forcefully expelled through the discharge port. Together, the casing, suction port, and discharge port form the primary external structure, directing the flow of liquids. The heart of the centrifugal pump is the impeller assembly. Notice the precise engineering of the vanes, designed to As the impeller begins to spin, it creates a region of low pressure, or a vacuum, within the pump's casing and Impeller blades. High-efficiency design. Curved vanes then impart centrifugal force, pushing the fluid radially outward and significantly increasing its velocity. This rotational motion transfers kinetic energy from the impeller directly to the fluid, increasing its velocity significantly. By the time the fluid reaches the tips of the impeller vanes, it has attained maximum velocity, ready to be discharged into the pump casing. The carefully designed curvature of the impeller vanes ensures efficient energy transfer, guiding the fluid.
This continuous acceleration significantly boosts the fluid's kinetic energy, which is essential for the next stage of the pumping process.
With its velocity maximized, the fluid is now ready to move from the impeller into the pump casing, where its kinetic energy will be converted into pressure. Fluid casing is where the critical conversion occurs, transforming high-velocity flow into the high pressure required for efficient operation. The impeller, highlighted here in orange, is the heart of the pump. It converts rotational energy into kinetic. Now, let's observe the complete fluid flow cycle within the centrifugal pump, a continuous journey from suction to discharge. The fluid is drawn into the impeller, where the rotating vanes begin to impart kinetic energy, initiating its acceleration. Within the impeller, centrifugal force dramatically increases the fluid's velocity, flinging it outwards with immense kinetic energy. As the high-velocity fluid enters the volute casing, its speed is gradually converted into high pressure, ready for discharge. This continuous flow from suction to discharge, powered by centrifugal action, forms the complete operating cycle of the pump.
There is an electronic track.
In this technical visualization, we see the continuous flow within the centrifugal pump. The fluid accelerates as the impeller rotates, it imparts energy to the fluid, creating a continuous flow. This is the centrifugal action loop.